Alright, so in this video we're going to be continuing with limits, and specifically we're going to be dealing with square roots. Okay, and it technically doesn't even have to be square roots. It can be, the third root or the fourth root or the fifth root, any kind of root really, but we're just going to be dealing with square roots because the same you know techniques will apply for any kind of root. So let's just get into our example. So we're going to take the limit as x approaches 1 of x minus 1 divided by the square root of x minus 1. Okay? And again, the first thing that we should always try and do with our limits is just substitute in the value 1 and see if it works. Now in this case, we're going to get 1 minus 1 in the numerator, which is 0. That's fine. But in the denominator, we're going to get, again, the square root of 1, which is just 1. 1 minus 1 is 0. We can't have a 0 in the denominator. Obviously, we know that. Okay, so we get 0 over 0. That's a problem. What would be our next step? Well, our next step would be to just try and factor. Now, I'm sure that there is a factor here of the square root of x minus 1, and I'm sure you could factor that, but I'm also sure that it would get very messy and that you don't want to do that. Okay, we really don't want to factor square roots. In fact, we want to do kind of the opposite. We want to get rid of square roots. Okay, and if we try and factor it, it's not going to turn out well. So we ask ourselves, okay, what is the best way to get rid of square roots? And the best way to get rid of square roots is kind of, ironically actually, to kind of do the opposite of factoring, which is sort of like multiplying, okay? So we're going to actually multiply. And what we're going to multiply by is we're going to multiply by the reciprocal. Okay, and specifically we're going to multiply by the reciprocal of wherever the square root is. Okay, so the square root is in the denominator, so we're going to just take our denominator of square root x minus 1 divided by square root x minus 1, but instead of multiplying by minus 1, we're going to multiply by plus 1. Okay, and that's all we're going to do. We're just going to do that multiplication. Okay, and we're allowed to do this because remember, the square root of x minus plus 1 divided by the square root of x plus 1, well, it's just 1. We're allowed to multiply by 1. We're not changing anything about our equation, right? So we're allowed to do this. And you'll see when we do actually do this, what we're going to do is in the numerator, let me rewrite our limit as x approaches 1. In the numerator, we're actually not going to even multiply out. We're just going to leave this as x minus 1 multiplied by the square root of x plus 1. It's going to be a little bit lazy. We're not even going to touch it. We're not even going to try and solve this. We're just going to leave it. But in the denominator, we are going to multiply. So we're going to have root x times root x. What does that equal to? Well, square root times the square root. That's going to get rid of the square root, and we're just going to be left with x. Okay? Then we're going to have the square root of x times 1. So that's going to give us plus square root. That was a very ugly square root, plus the square root of x. And then, remember, we gotta do the other multiplication of negative 1 times the square root of x, which is going to give us negative root x, and negative 1 times positive 1, which is just going to give us negative 1. Okay, and now hopefully you'll see why we don't want to distribute the top, but we do want to distribute the bottom, because in the bottom what we'll get is we'll get plus root x and minus root x, and they cancel each other out. And what are we left with? Well, we're left with the limit as x approaches 1 of our numerator, which is just x minus 1. Again, we're just leaving this as it is, times root x plus 1, divided by, in our denominator, we're just going to be left with x minus 1. And what do you know? After we've done this, there's something that can cancel out. X minus 1 is 1, and this x minus 1 goes to 1. And now all we're left with is the limit as x approaches 1 of the square root of x plus 1. And finding this limit, I'm sure you would agree, is extremely easy. Okay, now we know how to find this limit because we can just substitute in our value of 1 wherever we see x, and we'll get an answer that's really easy to get. So when we substitute in 1, we're going to get the square root of 1 plus 1. Square root of 1 is just 1. 1 plus 1 is 2. Bam, there's our answer. Okay, so whenever we see either square roots, cube roots, or any kind of roots, really what we should be thinking is this multiplication step, this very, very important multiplication step of multiplying by the reciprocal. Okay, so let's do one more example just to see that. So let's take the limit as x approaches 4 of the square root of x minus 2 divided by x plus 4. And again, the first thing that you should do is you should try to substitute in a 4, okay? And if you can substitute in a 4, then you're going to be great, right? Sorry, this should be x. This should be x minus 4. There we go. Minus 4. So obviously if we substitute it in, we're going to have a problem. We're going to have 4 minus 4 in the denominator. We're not allowed to have that. Okay, our next step should be, okay, let's try factoring. Again, I'm sure there is some sort of a factor here in the numerator that we could find, but I don't know how to find a factor of a square root. That seems like, I mean, it's just confusing. It's a lot of work. We don't want to do that. So instead, what we're going to do is we're going to take the limit as x approaches 4, and we're just going to rewrite this root x minus 2 divided by x minus 4. Okay, and then we're going to multiply wherever the square root is. In this case, it's the numerator. Just rewrite that as the square root of x minus 2 divided by the square root of x minus 2, and then just change the sign. So change this to a plus. Okay, and now we're finding the limit of all of this. Okay, so again, the limit as x approaches 4. And again, in this case, in the numerator, I do want to expand and simplify, because in the numerator, I want to get rid of these square roots. Okay, so in the numerator, I'm going to have root x times root x. Okay, that's just going to get rid of the roots, and we're going to be left with x. Then I'm going to have root x times 2, which is going to be plus 2 root x. Okay, then I'm going to have negative 2 times root x, which is going to equal negative 2 root x. And then I'm going to have negative 2 times positive 2, which is just going to be negative 4. Okay, and in the denominator, again, there's no need to expand and simplify. We're just going to rewrite this as x minus 4 multiplied by the square root of x plus 2. Okay, and now again, what we see in the numerator, we're going to have a plus 2 root x and a minus 2 root x. Sorry, those are going to cancel each other out. They're going to become zeros. Okay, now all we're left with is the limit as x approaches 4 of x minus 4 divided by x minus 4 times root x plus 2. And again, we have this cancellation. In the numerator, we're going to be left with 1. In the denominator, we're going to be left with root x plus 2. And so we can rewrite this as the limit as x approaches 4. Again, in the numerator, we just have 1. And in the denominator, we're going to have root x plus 2. And now, hopefully, when we substitute in our value of x equals 4, we'll actually be able to get an answer. And lo and behold, we do, because we get the square root of 4, which is 2. 2 plus 2 in the numerator is going to be 4. So we're going to get square root of 2 plus 2, or sorry, square root of 4 plus 2 in the denominator. Square root of 4 is just 2, so that's 2 plus 2 in the denominator. And we're going to get 1 over 4 as our final answer. Okay, so this is just a very specific way to deal with limits that include square roots. Now remember, in previous videos, we had limits with square roots, but that square root was applied to the entire function, and we were able to take out that root and put it as an exponent, and then deal with our limit without really considering that exponent because it wasn't important. Okay, in this case, we can't do that, okay, because if we were to try and do that, we still cannot solve our upper limit or our limit in the numerator and our limit in the denominator without having a problem. That problem being that if I were to separate this with a numerator limit and a denominator limit, the denominator is still equal to 0. And again, we can't have that. And same different kind of case here, or sorry, same case here. I split it into a numerator limit and a denominator limit. That's great, I'm allowed to do that, but my denominator is going to be equal to 0, and that's not allowed. Okay, and so that's why we need to have this specific way of dealing with limits that include, again, any kind of roots. It doesn't have to be square roots, it can be cube roots or any other kinds of roots, and all it requires is this very important step of just multiplying by the reciprocal. Okay, so wherever your square root is, you're going to multiply by the reciprocal of that. And then that's going to be able to help you simplify down your limit and hopefully find terms that will cancel each other out, and then you'll be able to solve. Okay? So that's everything that there is for dealing with limits with roots. In the next video, we're going to be dealing with piecewise functions and therefore piecewise limits, and we're going to see how we can solve those. It won't be too difficult, and it won't be, too crazy, but it is something that we need to discuss. So that's coming up in the next video.